Chemistry is a science that allows you to create some amazing and great concoctions.
Welcome back, everyone. Glad to have you back. And today I'm going to show you a chemistry app that allows you to view the elements as a three-dimensional visual simulation. So you'll have all the elements that are normally in the periodic table. As always, you could find the scripts in my GitHub channel, basically Snake Charmer Data. And don't forget to also see the episodes on setting up the Python environment, which allows you to import the libraries, and as well the how to create an executable. Essentially, what that will be is you can have an icon. It's an executable icon on your desktop. Double click, and you can run the program from there rather than through the VS IDE. So, without further ado, I think I know what you want, and that is to see the finished product. So let's take a look.
All right, so here we go. Um, in the middle of my desktop here, you could see a folder called Elements. First thing that I would recommend, of course, is always to create the folder, which will contain the files, including the executable file and basically all the other files that will run your script, your program, your application. The name of your folder essentially becomes your project name. So let's start Visual Code. And what we're going to do is we will import the folder. So we're going to open the folder elements. Here we go. Click open and the files appear at the top. At the bottom, we have our terminal, which is our best friend as always. The main script is where you will run the app, and the main script contains and is connected to, for instance, the the periodic table uh, window. So we have the script called periodic table window, which is then connected to another module, uh, which are the modules are at the top here. And this is a modular program. So let's click run and see what we get. And we see that it's been executed. It's right here. Yeah. And here we go. So what are we looking at and what does this do? First, it may come as a big surprise, but the I actually got the entire code from the NLP and pretty much started to run a program. It didn't have all the periodic elements at first, but I added that after. Essentially, it may be surprising to hear, but this was actually built within 3 to 5 minutes. So I'm sure uh, you would love to try out these scripts, just import them, create a folder, import them from the GitHub page. However, I do encourage you, and I'll show you what the NLP looks like in a moment, to give that a try first. And so here we have a hydrogen, which is the simplest element. So as you could see, you could spin it, you could zoom out, you could zoom in, and we could see the proton in the middle, the electron in a orbital, and we can also click on the bottom right. We have the rotation, so I believe this may be its natural rotation. Let's stop that. And we have a description. So we have the element information at the top. So we have the symbol, the atomic number, the atomic weight, the category, in this case, non-metal, electron configuration. It sends us to see the detailed reference. So it is in the description here. So we do have a little bit about hydrogen, and then we have the atomic structure. So we see one proton, one electron, zero neutrons, the mass number, and we see the orbital called the shell K, where the electron is located, which is the green one right here. Um, as we go down the table, uh, things get a little more complex in atomic structure. So we have lithium, so helium, lithium, and so on. Nitrogen, a little more complex. Of course, we have neon. Here we go. Potassium, even more complex. Let's zoom a bit out. And we have, let's go for titanium. There we go. So we could see titanium, for instance, has 22 protons, 26 neutrons, 22 electrons. The mass number is 48. The atomic mass, 47.867. Um, then we have, there are three orbitals involved. The k orbital has two electrons. There is the l orbital with eight, and the m1 with 12 electrons. Um, and let's see how this auto rotates. So we see one orbital rotating one way, another one the other way. Um, Very interesting here. And we have the protons and neutrons in the middle, clumped together there. So pretty cool. Very nice. This is atomic structure is held together by what's called the nuclear forces, and these elements are found and should be found throughout the universe with the onset of the Big Bang that exploded uniformly, and that is why these type of elements are pretty much everywhere around our universe. The, as they say, the fabric of the universe. And I could just spend a lot of time looking at this and spinning these. Um, let's go for germanium. More complex. Zirconium. This one has 40 protons, 51 neutrons, 40 electrons. Gadolinium, roentgenium, roentgenium. I think I'm butchering it here. This one has 111 protons, 171 neutrons, 111 electrons. Again, really interesting stuff. Um, Love it. Well, you get the picture, and I hope that you enjoy it. So let's dive into the code. Let's close that and back to the code. Now, how is this set up? Well, we have a couple of libraries. The We have our PyQt5, which is all the buttons, the functions, the filters. So those are part of PyQt5. Um, we have a periodic table window is not a library. Uh, this one is right here. It is actually one of the modules. Um, we have other modules here, which is element description, element data adapter. So element descriptions, element data adapter. Um, but the star of the show is NumPy. And NumPy is right here, as well as import math. These are the libraries, so import sys, import math, and import NumPy. Now, when you get your Python environment, essentially, uh, you will see it on the left side if you've set it up. But Do refer to my episode on setting up environments. Essentially, you know your environment is set if you see your elements environment. So that is pretty much set up in your Python virtual environment. So as you could see, it's modular. The NLP that I use here has provided me with a modular capability. It has, based on a very simplistic phrase, it's been able to uh, understand the definitions and the functionalities that I'm looking for. And one thing that I encourage you to do is to take this one step further. You've noticed in the program where there was a lack of description, like it was explaining what hydrogen is, but there's other elements that did not have the full description. What you could do as a bit of a fun challenge is to ask the NLP to provide you with a code to basically analyze the structure of your table and provide you with a code that will allow to fetch a description. Basically, what it will do is it will scrape the web. So it's going to be a web scraper application. And I would be very, very surprised if it doesn't use something called Beautiful Soup. Um, which is a web scraper that looks at information in the web and channels it in as data, and it will be built within the confines of your script. Um, so let's go to the GitHub page, but I just wanted to show you a bit more information here. So we have a description of what each part of these segments are, these coding segments. I will show you what classes are in one of the upcoming tidbits. You've seen tidbits on lists, tuples, and dictionaries, but I will have some tidbits on classes and objects because these are strongly related to one another. They have a powerful structural cohesion, and essentially, I will explain what those are, as well as I will be posting other tidbits. If you're new to Python, do take some time to watch those tidbits. You'll become really good at understanding the code in no time, and you'll be able to make a lot more sense. If you are a seasoned Python um, developer, all the power to you. So really great. I can't. I'm just awed at how quickly and effectively the NLP has provided this type of um, architecture and scripts. So in I want to go to the GitHub page. In the GitHub page, I have the 3D periodic table viewer README. So if you look there, you will have some information about setting it up for Mac as well as for Windows environments. So setting up the Python environment. At the bottom, um, you will have a project structure. So the project structure shows you the the files that you're going to need. So the main.py, the periodic underscore table underscore window.py, and all the other ones that are needed for this 3D periodic table viewer. Um, if you so you would need to import these, and the reason for that is very simple. If you go back, there's other applications under the main projects repository. So just to make sure that you download the correct files. And that is pretty much it. If you haven't seen, go take a look at the Collider episode. That is a fun one. That one is physics. It mimics a collider, and it is fascinating, as well as just seeing seeing the app about the elements, which really is th- just awe-inspiring, I would say. Um, so chemists are really involved, well, are involved in the molecular structure, the mixes that pretty much like making a soup with all the flavors and so on. And physicists uh, pretty much are concerned with the atomic structure of things and why they are the way they are, and the nuclear forces and energies. And then, if you're interested a little further in, I do recommend two authors. By the way, if you're interested in atoms and nuclear forces and um, the fabric of the cosmos, so one of them is Brian Greene, and yeah, Brian Greene has some amazing books um, on. I've got all three of these: the Elegant Universe, the Fabric of the Cosmos, and the Hidden Reality. Um, those are really great, especially when it comes to string theory. And another of my favorite authors are is Michio Kaku. Um, Michio Kaku, uh, who is also a physicist, and you'll also read up on some. He has some great books about string theory. They both write about parallel universes, multi dimensions. Great historical as well about the early physicists. Really interesting stuff, and thoroughly amazing. So I hope you enjoyed this episode, and I do encourage you to watch my other episodes and experiment as much as you can. Create different folders if you want to take it aside and start building from this script and going your own way, doing things your own way, looking how you can basically go from a 1.0 and take it to the next level like 2.0. You be you, just do you, and you'll be good. You'll learn a lot, and that's what it's all about. So thanks for watching. I really appreciate it, and I'll see you next time. Bye for now.